In part 2 of this series, we'll learn how to actually make the calibration level that looks like this. You can see we have good, great, perfect, and early and late indicators, along with misses. First, we'll need to make the level select screen for after the title screen. And we're going to make 4 levels: calibration, level 1, level 2, and the locked level 3. We do the construction initialization and set up everything in here. Then we make our update by doing the command number thing from the title screen as before in the last video. So once that's done, we can make a switch case to set up the state and substate accordingly when you press enter. For drawing, we make our background and draw select level. Then we make a for loop to draw everything else, including the ternary operator on whether it's locked or not. The ternary operator is basically an if-else statement, but really shortened, so you can put it in one line. And it looks like a question mark. We'll use it in a second to switch between the color white and color gray objects. For the actual calibration level, we'll want a simple beat tester. I had Claude put in comments, so don't mind any weird syntax. All the code is my own though. We initialize our important values and make all those imports, and then make fallbacks in case the song won't load in our public class calibration setup. Because this is a calibration level, we want to keep a history of the offset and RPA so we can make a cool results screen and show how the calibration is going to work. So we'll have an RPA history as an array list and offset history as an array list, which we'll make in a second. Now we can make our constructor to actually set up everything. So we initialize everything, then do a start level which does init notes, and in init notes we start the new array list for all of the notes. Then we look at the song class to load the chart for calibration, and we have a fallback just in case the JSON parser doesn't load, and so that helps us if something goes wrong in the JSON. To start the music, we try making a file object and loading it from the JSON, just like this. File audio file equals new file song path. And then if it doesn't exist, we have a fallback just in case to try and get it again. And if it doesn't exist, then we give up. Then we use audio stream to open it, and then we start it after turning down the volume a bit. To generate the beats, we use a beat value and target time. Then if the target time is less than when we render, we load it and add it to our index. Our update method is hefty, so we start the level, then when it's complete, we ask whether we want to accept or deny the calibration. Anyway, then we set the calibration offset, we make a tracker for where we are, using current time, generate beats, and then check whether it was a hit or not for each of the beats. So any note that was missed completely just disappears and renders as a miss. Then we find which note is closest to now, and we track that. Then for each note we get is its target time, and if it hasn't been resolved yet, then we track whether it was missed or not otherwise. Now if the closest note still exists and it's in the hit window, then we render a hit, and we track whether it was late or early, so particles point a certain direction, and then we record the phase angle and the offset. We also tier the scoring for perfect, great, and good for scoring purposes and to show how well you're doing. And then we check if a level ended by seeing if all the beats have gone through and if the music is still going. So if all the beats are done in your JSON and the music's still going, it won't end yet. We'll be drawing that in just a second. So here's our record relative phase angle method. And then to check the level end, we see if all the beats are generated and it's all empty, and then if the music is finished. Make the draw method, we make the background, the song title, the target ring, the score display, and then also the notes as they come, along with particles too. To make the notes, it's going to be a little complicated since we have to parameterize them as a vector sort of, tracking their position with time. So to make the notes, we let note x be target x minus seconds until hit times pixels per second. Anyways, make an instruction prompt and then particles, and we'll make a method for that in a second. Draw the end screen. We take the relative phase angles from earlier, and then we make the RPA plot, which requires us to make a graph using Graphics 2D. We plot each hit as a dot connected by lines and colored it by how accurate it was by spreading points out and color coding. Then to make a line, we use a stroke from a previous pixel to the new pixel. Then we have to change RPA to values of y, so whatever boundaries you specify will have to change here. Here's where we make our RPA into Y values, and then we make a reset method to make sure everything in calibration is all cleared up when we start it again. To spawn the particles, we make a new class for them and give them a velocity, and the direction will be random. So in our constructor we do this.x equals x, this.velx equals velx, such and such. And then the size will be random, with its update having an alpha that decays, so it loses transparency over time. As we spawn the particles, the velocity will be random, and it'll have a set x velocity, so we know which way it's going. Next, you have to make an away file, make a chart loader and a song chart and a note.java class in order to load everything. The JSON should also look like this. And as always, you can copy the code from my GitHub repo in the description.